Okay, the next topic in vectors here is going to be something called the dot product. The dot product is kind of a unique little formula here. Um, it's going to actually take two position vectors and with a series of operations, a little multiplying, a little adding and subtracting, um, go ahead and give us a real number. And that real number is useful for a couple different things when we're working with these vectors. But the definition of the dot product basically says that the dot product of two vectors is a real number, not another vector. So this is, in the past operations, we always got a new vector when we added or scaled or did any of those operations with them. Now, this dot product thing here is just going to produce a number. It's also sometimes known as the inner product or the scalar product of vectors. And the usefulness here, the dot product is used to help us determine the angle that is formed between two position vectors. And we've kind of seen the usefulness of that in previous studies of vectors here. So the dot product is very easy to find. If we want to find the dot product of these two position vectors, 6, -1, and 2, 5, we are going to follow a little formula here, but this is read u dot v. Okay, so u dot v. U is the first vector, v is the second vector. The little dot there doesn't really mean multiply, but it means we read it as dot. So u dot v is equal to a times c plus b times d. And our vectors here, our position vectors, if we have more than one, we would call that a comma b, and this would be c comma d. Okay, so what we do is we find the product of a and c, basically the x coordinates or the horizontal components of those two position vectors, find their product, add that to the product of the two vertical components. So, if we're calling this vector u and this vector v, to find the dot product here, we'd say, hey, u dot v is equal to 6 times 2 plus -1 times 5. Okay? Now, if we perform the order of operations here, 6 times 2 is 12, multiply first, -1 times 5 is -5, then add them up, we get the u dot v, or the dot product of vectors u and v, to be +7.